Gaspar Bakos is a professor at Princeton University and a renowned astrophysicist who has discovered over 140 extrasolar planets. He talks about growing up under the stars in Nigeria, navigating the Ucalyptin woods using only light from the stars, peeing next to a snow leopard, finding exoplanets using a robotic telescope he built, and being a professor. We also discuss the possibility of life in the universe other than on Earth, the possibility of humans relocating to another planet, the dangers of light pollution, and the wonders of black holes. Okay, so how did you get interested in astrophysics in the first place?
I think it started when I was a small child. We used to live in Africa with my parents and my sister on the northeast side of Nigeria in a small village. And we barely had electricity, actually. So one entertainment was to look at the starry sky. And of course, because there was that little power there was no light pollution. And the sky was very, very pretty. So, as a small child, I was often looking up and enjoyed the beauty of those thousands of stars and the Milky Way. And I remember I was asked my father about the stars. And on one of his ways back to Europe, he bought a small book and it had the constellations in it. And I remember the feeling of browsing through that book and I saw Orion in the book. And then I saw it on the sky. And there was this feeling of recognition or understanding something. That was really lovely. So that's where it started.
Can you talk a little bit about your travels? I know that you went around Australia and Namibia, Chile, and...
Yeah, so it's a bit of an unfortunate thing that these days to really see the beauty of the sky, you have to go very, very far from cities. It was not the case in the 19th century. One could see a gorgeous Milky Way from Boston, say, right? But because of the just absurd light pollution that we have, we actually have to escape as far as we can. And as part of my scientific career, I installed telescopes all around the globe that are fully automated. And as part of my job, I got to travel to these places to maintain them, usually about once a year. And some of the most remarkable experiences I had in astronomy are all connected to this. Like you mentioned Australia, where after flying into Sydney, it's still a 7-hour drive to go up to a small town called Coonabarabran, to the Warrumbungles National Park. And it's out of this world. One night, when I finished all my work, maybe a year or two ago, I decided to go for a night hike. And I parked my car next to the road and I just walked into the bush. And I think that's something people should experience. You don't need actually a light. There's no venomous snakes in the area I went, I have to add, but you can actually walk through the eucalypt woods and the bush just by starlight. And you see the Milky Way, you see the zodiacal light, you see something called the Gegenschein on the sky. And at the faint starlight, you see all this dark silhouette of the trees on the sky. You hear nature around you. You become an integral part of it. Of course, all these animals know that you're there. They know much better than we know where they are. And I was just walking all night, absorbing all the beauty of the cosmos, because I think we're extremely lucky that we have clear skies from Earth. We could live on a planet somewhere in the universe which is always clouded over, and aliens on that planet have no idea about the stars or galaxies or anything. But we're really lucky. I have similar experiences from walking through the Kalahari Desert in Namibia. People should just see that, not in a photograph on a screen, but the whole feeling of the Milky Way going down to the horizon, seeing sand dunes, all the ripples on them at starlight. It is really gorgeous. And I'm quite worried actually that we're losing that all around the globe.
That reminds me, I think the one time I saw something like that was when I was in Israel and we slept over in the desert. We just had sleeping bags like on the sand. And then I woke up before anyone else woke up and nobody had any light, but it was still so bright because of the stars. And it was just the most beautiful thing to wake up to. I felt like I was still dreaming. It was just so gorgeous.
Yes, at least you saw it. It must have been in the Negev desert, right?
Yes.
So we used to have a telescope actually next doors, and I can confirm that the sky from that part of Israel is stunning.
What are some of the coolest things that you've seen or found when looking at the sky?
Oh, that's an excellent question. The coolest things I've seen, if the sun sets, occasionally you see something called a green flash. It's on the top rim of the sun. It can get really dark green. Sometimes you actually see something called a blue flash or a violet flash on top of that. I've seen that many times as the sun sets above the Pacific Ocean from Chile. What amazed me was that you actually see a green flash for the moon setting, and I've even seen one for Venus. Just just for a second or something. It's a very subtle thing, but it's really very pretty. Another thing is that the plane of the solar system, the ecliptic, has this fine dust, millions and millions of particles of just fine dust in a big disk, like a pancake. And the sun illuminates that on the sky. You need very dark skies to see it, but it's called the zodiacal line. And right opposite to the sun, that means like in the middle of the night overhead, is a patch, like a cloud, which is all this dust reflecting light exactly backward towards us. It's called Gegenschein. Another thing is, which is not that well known, is the atmosphere has some light emission on its own. In the daytime, it's irradiated by the sun, and in the nighttime, it's not just infinitely dark, it's not pitch dark, it has a color to it. And actually, there are these waves moving in the atmosphere like a barrel above your head. So you can see this faint glowing structure of like fingers moving above your head on the sky. Now you need really special conditions for that to happen. And you also need to be very dark adapted, which means in the daytime you wear sunglasses, you eat a ton of carrots to build up all the necessary vitamins in your eye. I think most people have actually never in their life experienced real dark adaptation because they just take a couple of minutes and they see something in the dark. That's when their pupil dilates. But following that, there's a long phase of lasting many hours during which you build up rhodopsin on your retina, and that is extremely sensitive to light. And that's when you actually really gain night vision. You need to be at least an hour, but preferably 2 or 3 hours in very dark conditions, and no iPhone just for a second checking your email, because then it spoils the whole thing. And so I think most of the phenomena I've seen, a condition to those is that you're really dark adapted. I've observed from the summit of Mauna Kea at Hawaii, which is at something like 13,000 feet. And the sky from there is very, very pretty, except another problem kicks in, which is you don't have enough oxygen. And it means that your brain is deprived and your retina is deprived of oxygen, and you actually don't see well. How annoying that is. Now, the remedy for that is you actually have to suck on oxygen from a big canister, or it's like what's used for medical supplies. And inhaling oxygen at high elevation really boosts your night vision, and then you can see very faint things. One thing that I really liked, speaking of Hawaii and Mauna Kea, is you can see the volcanic eruption which was going on at the time with its very dim red light illuminating the clouds from underneath. And you see all the clouds in the Milky Way setting right above that. And if you use a telescope, you actually see things that are fascinating. One thing I remember seeing through a telescope for the first time in my life was the spiral structure of a galaxy. All you see with a small telescope is a little fuzzy blob. The amazing thing about it is if you look at it with a big telescope, it has this spiral structure. It has a core and it has these spiral arms going out. And we have sketches by these astronomers. But when I saw it to my eyes, like the first time, through the eyepiece, that's fantastic. And it's very different than seeing it on your screen through the Hubble Space Telescope images. I think you remember that yourself. You've come to many star parties and looked through the telescopes, and it's just a different feeling to see it for yourself, in your own eyes.
It is very different, even though it's, light years away.
Well, actually, in this spiral galaxy, I had an adventure with this because I was making a sketch with a pencil, and it's completely useless, because all the photographs are so much better. But sometimes we do things that are completely useless, and this was one example of that. But the side effect of actually you have to draw something is you have to really pay attention to all the details. So you spend actually hours and hours sketching this, and you see more. You see far more than just the casual let's glance through the eyepiece. And next month I went back to finish up my sketch, and there was a star in this galaxy at a location where in my previous sketch there wasn't a star. And I thought, well, either I made a mistake, but I don't think I would have missed it, or it's a supernova. Oh my God, it's a supernova. Let's rush down to the village, find that phone booth, call up someone because that's a supernova. So by the time we got down next day, it was announced as a supernova because other people also discovered it. But I still feel the thrill of seeing it for the first time through the eyepiece and based on my own sketch, recognizing that this is a supernova.
Wow, that's amazing. Traveling by yourself through so many countries through the dark. Did you ever have any scary experiences for the sake of research?
I think the most dangerous things in the world are people, actually, with guns, and bureaucrats who would stop you at an airport not having a visa or something, and things like that. Wildlife is all gentle compared to that. Once I went to Namibia, and in my room there was a snake, and I was just extremely tired. So I really felt pity for the snake, but I threw a big stone on it and killed it. I remember taking a photograph of a gorgeous canyon in Namibia on my way back to the farm where I live when I visit. And then I realized it would be very cool if I climbed up to these rocks and my camera would take a picture of me standing on these rocks in front of the sky. I set up the camera. It was taking exposures every minute or something. And in the night, I climbed up and I stood on this ridge. The next day, the guy says to me, well, that's called Leopard Canyon. It's a big cave where a leopard may still live there. So I may have been climbing right above the cave of a leopard, and I think that would have been an unpleasant meeting.
Oh my God.
That's another one. I forgot about that. So that one was in the Himalayas. That was in India. It was a very high altitude observatory. So on the way there, you stop in a village, which is already at like 9,000 feet or something, and you spend a day there. And then most people spend like 3-4 days before driving further up to the Himalayas. But I was in a rush, so I decided to go as fast as I can. And you can do it if you take a medication for altitude sickness. So I took that medication, and the side effect of the medication, I have to tell, is that you have to pee every hour or two. You're constantly drinking and peeing. So on the way up, that was with some colleagues there, we stopped for a short break, and I climbed a bit off the road into these rocks. There was these giant slabs, all gray, and just as I started peeing, one of these giant gray rocks moved literally next to me. And I just realized it's a snow leopard. So I froze for a second and I rushed back to the car for my camera and then started running and taking photographs of this. And, the funny thing was that it was so close to me that it was literally a couple of steps away, and I didn't notice it till it actually moved. And I'm so lucky that it decided to move the other direction and not towards me. I met teams on the airport. I actually met a team of biologists who were flying to the Himalayas for a 3-week trek to see snow leopards. And the guys said that they would also be happy if they just saw just the track of a snow leopard, just the footprint on snow. But that would be a big deal already. And they have been there many times in the past years, and they have never seen a snow leopard. So
Wow.
they're really hoping once they will see one. And so here I am. I'm just going to do astronomy, and I stumbled across one of the best scenes. I was very happy with that. It was a very relaxed snow leopard. I think it actually yawned at me and it just stood up and just slowly started to walk away and look back at me. It had this giant tail. It sort of curled a bit, the tail. And I had the feeling that he or she is the boss and I'm just a visitor here. And right now, he decided to tolerate me.
So can you talk a little bit about your research?
Yeah, I think the main profile in astrophysics I've been pursuing is extrasolar planets. So these are planets that orbit other stars, not the sun. And they're very hard to find because the stars are bright compared to the planets, and the planets are very close into the stars. So the glare of the star is making it very hard to see the planets. But there's a trick around this, is that the planet can go in front of the star if the orbit is aligned with our line of sight. Now this way you can actually see the star blink every orbit of the planet. So if the planet goes around 1 year, then you will see a blink every year. It turns out there are planets that go around stars much faster. They orbit stars just with a period of a couple of days. So what I did was I built a robotic telescope that would take images of 100,000 stars every 4 minutes, fully automated without an astronomer actually looking through an eyepiece or pushing a button. And we also developed software for analyzing all the light of all these stars to see if any of them was blinking in a periodic way. It took a while, and after years and years of running this thing, we actually found an exoplanet, which is called HET-P1. HET stands for Hungarian-made automated telescope, and P stands for planet. So HET-P1 I was quite happy, I have to say, because I I found a planet. And it was something like Jupiter. It was a hot Jupiter, something orbiting very close in. And that was just the beginning. Then we started to build more telescopes and more sites and improve the software and have this network observatories in Chile, Africa, and Australia. Right now, we have about 140 discovered, except for the
I can't believe you
coronavirus.
found over 100. That's incredible.
Yeah, it's 140, and they're mostly hot
140.
Jupiters, but there are some of the first kind, like we found the first transiting Neptune-sized planet.
Could you talk a little bit about what you think of the whole question of, are we alone in the universe? Or do you think there is a planet out there somewhere that holds life in some way similar?
Sure, if we ponder about the probability of life elsewhere in the universe, then if you want to calculate that, you start with some assumptions about how we live. I know they are assumptions, but if we knew how many rocky planets there are in the universe that are like the Earth, we would have a much better handle on the probability of life. It turns out we had no idea about this fundamental question 25 years ago. We only knew that the solar system has 8 planets, 4 rocky and 4 gaseous or icy. So the past 2 or 2.5 decades in exoplanet research showed us that overall there are about as many planets orbiting stars as stars. Now, most of these planets are not habitable, either because they are gaseous, like Jupiter. It doesn't have a surface. You would just sink till you, under the high pressure, get really compressed into something and or disintegrate. Or some of these planets are just too hot or too cold for life. But there is something called the habitable zone. It's not too close, not too far from a star, just right at the right distance where conditions can be good for liquid water. Not surprisingly, our Earth is in the habitable zone. A little more surprising is that our Earth is in the very inner edge of the habitable zone. If it was pushed in a tiny bit or the sun got warmer a tiny bit, we would exit the habitable zone. That's a bit concerning, actually, given the global warming. The outer edge of the habitable zone is not far from Mars, for the sun. Over these 25 years, we also learned that the number of solar-type stars that are similar to the sun that have a rocky planet in the habitable zone is about 10%. That's an extremely important number. So it means if the galaxy has 400 million stars and some of these stars are sun-like, let's say there are 10 million stars that are almost exactly like the sun, I just came up with a number, then 10% of them have a rocky planet in the habitable zone, which is 1 million. And I gave here a conservative underestimate. The takeaway point is that our galaxy has millions and millions of rocky Earth-sized planets around solar-type stars. And this is now not a hypothesis, this is a result of 25 years of research and discovery of planets. Now we have 1 trillion galaxies in the universe, each galaxy having about 1 trillion stars. So you multiply these numbers, the result you get is that the universe has probably trillions of Earth-like habitable planets. Now,
Wow.
What's the probability that actually life has not developed on any of these? That would be really surprising, I think, if we were so unique. We are unique for certain reasons, like we have a big moon which stabilizes the spin of the Earth, which means that an area on Earth which is a jungle and it's tropical remains a jungle and tropical for an extended time, meaning millions of years, instead of the Earth suddenly tipping on its side and that area becoming a polar area with ice cover. So you can say we are very special, we have a big moon, but I don't think if you have 1 trillion Earths in the universe, I'm sure some of them have a big moon. I can't imagine we're so unique. Then others say, well, we're also unique because we have a Jupiter. Jupiter is the one that perturbed the asteroid belt and sent all these icy asteroids on a collision course to Earth. And once they actually collided with Earth, they deposited all the water on Earth. Initially, Earth, when it formed, was just a rocky bowl of lava. There's no water on it. So once it started to solidify and all these asteroids hit it, it accumulated water on it. All the water we see anywhere, anything that comes from your tap, you get the ocean, is from asteroid impacts. And that's thanks to Jupiter. So you can say, well, we are very special. We have a Jupiter. But I think if you have 1 trillion planets, there must be some other planets which have a Jupiter outside. So I think what I'm trying to tell here is that I think the probability of having life elsewhere in the universe is very, very high. And then you can go on and ask, what's the probability of having intelligent life? Because if you look at Earth, we had something like 3.5 billion years of life on Earth. And out of those 3.5 billion years, it is only in the last 100 years that we can actually send radio signals to outside the Earth, or we can launch a rocket. I mean, 100 years out of 3.5 billion is really nothing. And I'm also unsure about the fate of mankind, because I wouldn't bet a big sum on us surviving for another even 1,000 years, let alone hundreds of thousands of years or millions of years. So an intelligent life on a planet may be actually very short-lived. Overall, there's many planets, many rocky, many habitable, and I'm sure many of them develop life, but having intelligent life, that's definitely much less of a probability. And then this is where it becomes a real stretch. Those visiting us, landing with a flying saucer, eating our ice cream or abducting our wife or husband, that's not really true.
Like, even if they lasted longer than humans have, I mean, we're not even to the point where we can go to another planet that is not in our solar system.
You're exactly right. We can't go to another planet. There's an experiment, there's a project which is trying to sail over to another planet. It's a fundamental problem with space travel is that the faster you want to travel, the more fuel you need. But the more fuel you put in your rocket, the heavier you are. And there's an equation that shows it's just extremely hard to go fast. You need to build an enormous rocket. But another idea is you actually don't take any fuel with you. You just open a giant sail and you shoot a laser from Earth to accelerate this spaceship. And as it accelerates, it can go up to like 20% the speed of light. So that's a possibility to go to the nearest star in about perhaps 20 years to get to the nearest star. And that would not be a human. It would be a microchip traveling to the nearest star just to take an image and send it back. You know, it's very, very hard to travel right now.
How likely do you think it is that humans will be able to relocate to another planet before Earth becomes inhabitable?
Well, I think the closest one is Mars. I mean, humanity, if all our knowledge was combined and all nations were peaceful with each other and there was no spending in military and defense, but everything was going into just making this world better and collaborating, we would easily fly humans to Mars and we could establish a base on Mars. That's entirely within the scope of technology. And so you would build big domes on Mars, you would take people to Mars, you would need supplies at Mars, and you could start a colony on Mars. And Mars is much further out than Earth. So as the Earth slowly becomes uninhabitable, as the sun grows to be a red giant,
And Mars will become hotter as well.
Yeah, it will become hotter. It's too cold right now, except for at the equator. But it will become warmer and it will become slightly more habitable, actually.
Do you have any interesting ideas about the Big Bang?
I think cosmology is really, really fascinating. I have not myself contributed anything to it. I think a great reason, which you don't see with your eyes, but gravitational waves of colliding black holes or neutron stars that stir up space-time during their last bit of orbit and the collision itself.
As you explain this, can you talk a little bit about black holes?
I think it's fascinating that you have an object in space which does not really have a finite size, but it has a little sphere around it, and no light and information can exit this little sphere around it, and it's so enormously dense. But actually, if you have a black hole in front of something, there's many, many stars here, there's a black hole here in the center, the starlight goes next to the black hole. The black hole's gravity is so strong it will bend the starlight. So you can actually see black holes implicitly through the bending of light. Black holes seem to be very simple objects in some sense. You can't say this black hole is red or it's wrinkled or it's hairy. It's a black hole. It has a mass, it has a spin, it has a charge. It's a fairly simple thing to describe, right? And what's interesting to me, for example, is there are black holes that have millions the mass of the sun. They have been patiently collecting mass like a big vacuum cleaner in space. Anything falls in, stays there. Our own galaxy has a giant black hole, a supermassive one in its center.
Do they ever get bigger volume-wise, or are they just the same volume and collect mass?
The volume is the tip of this pencil. but the horizon around them in which light cannot escape is growing. That's a function of the mass. The more massive the black hole is, the bigger the sphere around the black hole through which light cannot escape.
So it just gets denser and denser.
Simply, yes. And another thing is that black holes actually can collide with each other. And it was predicted that when two black holes collide and they're losing energy because they're stirring up space-time and gravitational waves radiate away from the system, so they're going in closer and closer. And in the end, these two black holes actually collide. And at the end, there's this enormous output of energy, but it's not in the form of light. It's not something like a big explosion, you see a big flash. No, it's in wrinkles of space-time. It's in gravitational waves, but the energy can be so enormous that for a very short time, the output can exceed the entire energy output of the universe. So,
wow.
And these things have been discovered now. Gravitational waves have been found by the LIGO observatory. They pass through the Earth. You won't feel them you won't feel like, oh, wow, I'm shaking because there's a big gravity wave coming through. It's a tiny, tiny perturbation to space-time because it happened very far away from us. But it has been detected now for many objects. It's the space-time we live in, or the dimensions of things, that's distorted. But if you go close to a black hole, the space-time is permanently distorted. The closer you get, the more it's distorted, both space and time. For example, time runs much slower. If you look at the movie Interstellar, when someone travels close into the black hole and comes back to the spacecraft, everyone on the spacecraft is old. The person who went in and came back is very young. Now, for the gravitational waves, it's also a distortion of space-time. It's just not permanent, like right next to a black hole.
Very cool. Is there anything else you want to talk about?
As you know, I've been very strongly fighting against light pollution. And the reason is I just really want all this beauty of the sky to be preserved for people. But I also, over the years, I realized how important it is for nature to have dark skies, for birds navigating by the stars, for beavers outside in dark so they're not caught by a fox or a coyote, or just insects so they survive, they don't fly into the bright lights and die by millions. And I think what you're doing on Earth with light is just terrible. And I'm not saying things should not be lit, but there are many lights where the lights are aimed up or sideways, many is just directly up in the sky. And I don't understand how that's not changing. I'm fighting because I want to preserve it for students and for my children and for other people and for nature.
So last but not least, why do you love being a professor?
Well, that's interesting. I think I was moderately enthusiastic about teaching in the beginning. I was doing more research before that, and I thought I would lose some time doing research. But then when I started teaching at Princeton, I realized this is really fun, and my students are really very good. I enjoy interacting with them a lot. I really encourage them to come to visit office hours, go to star parties. I mean, look at that. We're doing an interview over the phone. You finished at Princeton many years ago, and we still keep in touch. Of course, you were one of the best students. That's you're distinguished in that sense, but still.
This has been so interesting. Thank you so much for willingly interviewing with me.
Yeah, I enjoyed it too.
That was the world-famous astrophysicist Gaspar Bakos. If you enjoyed this interview, please like and subscribe to my channel.